Okay, today we are solving multi-step equations. So the goal is still the same. I'm still trying to get my variable alone on one side of my equal sign. So my answer should look something like this. X equals or Y equals. And it should just be some number. That's all I'm looking for. But these are going to be a little more complicated than the last two ones of solving one step and solving two step. We have three different types we're going to talk about today. The first one is solving multi-step equations with variables on both sides of the equal sign. If I look at my first example, I have 5y minus 2 equals y plus 10. I have a y on both sides of my equal sign. What I want to do is move over the smaller variable to be with the larger. So I look and I say I have 5y, I have 1y. Which one is larger? Well, my 5y is larger, so I want to subtract 1y from both sides. So now those y's cancel. All I'm left with is equals 10. 5y minus y is 4y. Bring down your minus 2. So you have 4y minus 2 equals 10. Well, this looks like something we did yesterday. How can I get my y alone? Well, I could add 2 to both sides, and I get 4y. Those 2's cancel, equals 12. Divide both sides by 4. Y equals 3. Your final answer, your variable should be all alone, and it should equal one number. Let's take a look at the second one. I have 7x plus 19 equals negative 2x plus 55. Which one is smaller, 7x or minus 2x? The minus 2x is smaller, so you want to add 2x to both sides. Both sides of what? Both sides of this big blue line. Well, 7x plus 2x is 9x plus 19 equals negative 2x plus 2x cancel out equals 55. Well, now you have 9x plus 19 equals 55. And you're going to get that x alone, so you want to subtract 19 from both sides. Those cancel. 9x equals 55 minus 19 gives you 36. Divide both sides by 9. So your x is all alone, and you get x equals 36 divided by 9, positive 4. And that is your final answer. So we have another type of kind of multi-step equation, a little more complicated. And this is when I'm combining like terms. Well, if I look at my equal sign, I draw a big old line down my equal sign. 7x minus negative 2x plus 2 equals 2x plus 14. If I have this minus, what can I change that to? Didn't we say I can make those pluses? Well, if I have 7x plus 2x, I get 9x's plus 2 equals 2x plus 14. Now, doesn't this look like what we did on the last page? I want to get the smaller variable, that 2x, to be with that 9x. So I subtract 2x from both sides. Look at how I'm lining up my problems. I'm using columns, and I'm putting my variables in the column with their like term. 9x minus 2x gives me 7x plus 12 equals, those 2x and negative 2x cancel, 14. Subtract 12 from both sides. Both sides of what? Both sides of this big line going down my equal sign. Those cancel. 7x equals 2. Well, if I divide both sides by 7, x is all alone, and x equals 2 over 7. Miss Sawyer, that's a fraction. Miss Sawyer, that's a fraction. Can I have a fraction as my answer? Is a fraction okay? The answer is a fraction. That is okay. It's okay to have a fraction. We have fractions all the time in real life, so we're going to have them in math class. If you're ever doubting yourself, just remember, you know how to do this. It's just a few more steps. That's all we're doing, just adding a couple more pieces to my problem. So now I want to do ones with the distributive property. So distributive property means I have to distribute first. So I have a 3 on the outside of my parenthesis. 3 times x, 3 times 11. Well, 3 times x gives me 3x. 3 times 11 gives me plus 33. Bring down the rest of your problem. Now this looks a lot like the stuff we did at the beginning. I have a variable on both sides of my equal sign, and I need to jump over this big black line to get those variables together. Well, which one is smaller? I have 3x and I have 10x. The 3x is smaller, so I'm going to subtract 3x from both sides. Now look, your variable is going to end up on the opposite side, but that's okay. It's still going to be alone. Once we do a couple more steps. I have 33 equals negative 2 plus 7x. Add 2 to both sides. 35 equals, those 2's cancel, 7x. Divide both sides by 7. 35 divided by 7 equals 5, and you get 5 equals x. Is x all alone? Yep. Even though it's on the other side, this is your final answer. This is correct. X equals 5, or 5 equals x. If you want to write it like this, just, for your own sake, you can. These are the same exact thing. So we have a couple things called special cases, or those problems. I know you guys have heard about those problems before, ones that you think are tricky, ones that you think are annoying, ones that you don't like. Well, we're going to go over some of those today. We have 2 cases, case 1 and case 2, of my special cases, or those problems. Let's take a look at my first one. My first one says 9x minus 4 equals negative 3x plus 5 plus 12x. Well, if I draw a line down my equal sign, I'm going to combine like terms because I have negative 3x plus 12x on one side of my equal sign. What's negative 3 plus 12? It gives me 9. I got to attach that x again. So I get 9x plus 5 on one side and then 9x minus 4 on the other. Well, if I subtract 9x from both sides to get my variables together, 9x minus 9x cancels. I get negative 4. Uh-oh. 9x minus 9x cancels on this side too. And all I'm left with is a 5. Does negative 4 equal 5? Negative 4 doesn't equal 5, does it? 5 equals 5. So look over here on the left side. If your end statement is not true, meaning you get something like this, negative 4 does not equal 5, it's not true, your answer is no solution. Meaning there's no number I could put in for x to make this problem equal itself. So your answer, you would just write no solution. And that would be your final answer. That's case 1. That's one of my special cases, but I said we have 2. Let's take a look down here. 10x plus 12 equals 2 times 5x plus 6. Draw your big line. I have to distribute that 2 first. 2 times 5x, 2 times 6. Well, 2 times 5x gives me 10x. 2 times 6 gives me plus 12. Bring down the other side. Hold up. Don't these look the same? 10x plus 12 equals 10x plus 12. Isn't that the same thing on both sides of my equal sign? The exact same thing, 10x plus 12 equals 10x plus 12. Look over here on the left side. If your end statement is true, meaning you get the same thing on both sides of your equal sign, your answer is all real numbers. Meaning I could put in any x I wanted to, any number for x, and that statement would be true. Let's try it. What if I put in 0? 10 times 0 plus 12 equals 10 times 0 plus 12. 10 times 0 gives me 0. So 12 equals 10 times 0 equals 0. Does 12 equal 12? Yeah. So your answers for these types of problems where it's the exact same thing on both sides is all real numbers. That's all you have to write on your paper. So flip your page over and try these on your own.